All right, I just wanted to show you for our check-in what I was kind of expecting for number 3 in particular, how it says to use your graphs. So a lot of you guys were solving the absolute value equation. You were doing it correctly, but I wanted you to use your graphs to really see the relationship between the graphs and the equations. So the first thing that it asked you to do in number 2 was to graph the functions. So we have the absolute value of x minus 5 here. So an absolute value function is that V shape. The minus 5 is a transformation. It's moving us to the right 5. And the way that you could think about that is that if x is equal to 5, then we're going to get a 0 there. So 5, 0 is now on our graph. So I'm going to plot that point, 5, 0. And then remember the way absolute value grows is it just goes right 1, up 1, and right 1, up 1, and left 1, up 1, because all of these negatives that we used to get would be positives now. So we have this V shape. Connect the dot here. All right, and you could verify those points. So when I plug in a 6 to this equation at the top there, 6 minus 5 is 1, absolute value is 1. If I plug in a 4, 4 minus 5 is negative 1, but its absolute value is 1, so you could see where these points are coming from here. Now it also wants us to graph g of x equals 2. Now you see no variable on the right side. That means we're a constant function, which means that we have a horizontal line where every output gives us 2. So we have our f of x function graph there, and we have our g of x function also graphed here. So majority of you guys did this perfectly. You have your graphs going on, and so then to use the graphs, we want to use them to solve this equation. This equation is really asking, well, when does our function f of x equal our other function, which is our g of x? And you can see that they are equal to each other at these little crossing points here, which they happen when our x values, you can go down, when x is 3 and when x is 7, based off of my picture. So it looks like the answer for number 3 is going to be x equals 3 and x equals 7. And you can see that just from the picture. So without actually solving it algebraically, which is what majority of you guys did, you can just look at the picture and see that it looks like 3 and 7. And so for number 4, it wants us to double check that. And so if we want to check that we're right, you're just looking at this equation that we're trying to solve here. And I'm going to plug a 3 in to check. So if x is equal to 3, we're going to have 3 minus 5. And we're not sure, we need to check that this is going to be a 2 here. Well, 3 minus 5 is negative 2, and its absolute value is 2, so that works. And now when x is equal to 7, the absolute value of 7 minus 5, we want to see if that's equal to 2. Well, 7 minus 5 is 2. Absolute value of 2 is 2. That checks as well. So this was part 4, and again, this was part 3. So this is what I was looking for. Again, if you solved it algebraically, most of you guys were doing that, which is okay, but I had asked you to do it by graphing. So algebraically, most of you guys did it correctly if you did it algebraically, but a few of you were missing one, and what I mean by that is we're saying the absolute value of some number equals 2. Well, that some number, which is x minus 5 here, that expression, could be a positive 2, or it could be a negative 2, and I just wanted to make sure we were all okay with that, because you need to make sure that you're getting these two answers, which you could see that there were 2 meeting points over here, and we get x equals 7 and x equals 3. So again, a lot of you guys showed this part over here, which was algebraically. I just wanted you to look at the graph though, and you can see that it meets at x equals 3 and x equals 7. So hope this helps. Have a great week.